Welcome to you all to Go Physics. Now we'll see a lecture series of disconnecting and reconnecting of capacitor. This is the lecture number 1, and today we will deal with case 1, in which we will have one capacitor that is connected to a battery, due to which the capacitor will get charged. And once the steady state will reach, that is once the capacitor gets fully charged, we will remove the battery and then we'll connect to this charged capacitor to this initially uncharged capacitor. And in the final condition, we have to find the charges on both the capacitor. So let's see. Due to the battery, the left plate of the capacitor 1 will acquire positive charge and the right plate will acquire equal amount of negative charge. Let us consider this charge is Q1 and Q2 is 0 because this is initially uncharged capacitor. Now once this capacitor gets fully charged, we removed this battery and then we connected to the capacitor 1 and capacitor 2. So what will happen, some positive charge from plate 1 will move on this plate of capacitor 2, and similarly some negative charge from capacitor 1 will move to capacitor 2 on this plate. This movement will be due to repulsion. On this plate positive charge are repelling each other and on this plate negative charge are repelling each other. So let us assume 3 positive charge left here, and so 2 positive charge reach on this plate, and similarly 3 negative charge is here, and 2 negative charge reach to this plate. Let us assume this is Q1 dash and this is Q2 dash, and similarly this will be minus Q1 dash and this will be minus Q2 dash. So if we want to know what is the magnitude of Q1, so Q1 equal to C1 into V1, that is voltage across the capacitor 1. And what is the voltage across the capacitor 1? This is the total voltage of the battery. So Q1 equal to C1 into V. This is the initial charge present on the capacitor. And initially the potential across the capacitor is V, that is voltage of the battery. And once the charge get redistributed, the voltage will change because the charges on the capacitor is changing. Let us assume voltage on capacitor 1 is V1, that is potential difference, and potential difference across the capacitor 2 is V2. Now apply Kirchhoff's voltage loop law in the final situation, KVL, Kirchhoff's voltage law. I am moving clockwise. So I am moving clockwise and I am leaving the negative plate, so minus V1, and now I am leaving the positive plate of capacitor 2, so plus V2 equal to 0. From here we got V1 equal to V2, and let us assume this is equal to V. That is in the final condition, the charge will move from plate 1 to plate 2 till both the plate will acquire a common potential V. And as we know that Q equal to CV, so in the final situation V1 will be Q1 dash by C1 and V2 will be equal to Q2 dash by C2. And from charge conservation we can say that total initial charge is equal to total final charge, and total initial charge is Q1, that is I am writing here from charge conservation, total initial charge is equal to total final charge, and total initial charge is Q1 only because Q2 is 0, and total final charge is Q1 dash plus Q2 dash. Let us assume this as equation number 1 and this as equation number 2. we have two equation and two unknowns. Now from here q1 dash is equal to q2 dash c1 by c2. Put this value of q1 dash here. If we will substitute, I am writing this equation once again. q1 dash plus q2 dash is equal to q1, and q1 dash is equal to q2 dash c1 by c2 plus q2 dash is equal to q1. From here take q2 dash common, so it will become c1 by c2 plus 1 equal to q1, and from here q2 dash is equal to c2 by c1 plus c2 multiplied by q1. So this is the final charge on the plate on the capacitor 2. And what is the final charge on capacitor 1? That is q1 dash. Put q2 dash here. So q1 dash is equal to q2 dash, where q2 dash is c2 by c1 plus c2 multiplied by q1 into c1 by c2, c1 by c2. c2 get cancelled out. So from here q1 dash is equal to c1 by c1 plus c2 into q1. So these are the final result we arrived. And also remember this final result to solve numericals if coming in NEET or JEE paper. Okay, thank you.